Hi, today we're going to be focusing on the incline planes, right? So now we will look into objects in motion and objects that are stationary, right? So it's very important that we look into these different types of objects so that we are able to identify their net force that is acting on it, right? Let's look into objects in motion. So we have our incline here, and an object which is 1 kilogram, and it has an applied force, right, at an angle of 30 degrees. So not forgetting that the slope or the incline is at 10 degrees. So now the first thing we're going to do is we're going to establish the forces that are acting on this object. So the first force we're going to establish is the force of gravity, and then we have the force that is perpendicular to the slope, and then we also have the force that is parallel to the slope, and we have the normal force, right? So the first thing that we can do now is to first identify the normal force of the object, right? So the normal force, there are two forces that have an influence in identifying the value of the normal force. So the first one is the force that is perpendicular to the slope, and the second one is the force applied, right? But in this case, because the normal is vertically upwards, perpendicular to the slope, there's also a force here that is vertically upwards, right? So we're going to look at forces that are in direction with the normal, which is this force here, which is force applied but in a vertical direction, and this force perpendicular here. So, but if you take a look, this force perpendicular is going downwards, and this force applied in a vertical direction is going upwards. So let's choose up as negative and down as positive. So if we are going to identify the normal force of this object, we're going to say we have the force of perpendicular, which is going downwards, and minus the force applied but in a vertical direction, which is going upwards, right? So this is the normal force of the object, but we need to identify the values of the F that is perpendicular and the force that is applied but in a vertical direction. So how do you find the force that is perpendicular? So we know very well that here, this is our triangle, it's right angle, and because here it's 10 degrees, which means that it's also going to be 10 degrees here. Because we are looking at the force that is perpendicular, we're going to look at the adjacent side, which is this one here, the adjacent side of the triangle, right? So we're going to say cos of 10 degrees is equal to the adjacent side, the force that is perpendicular to the surface, divided by the force of gravity. So the force of perpendicular, so you're going to cross multiply, is going to be equals to the force of gravity multiplied by cos of 10 degrees. So this will be the value of the force of the perpendicular. So now let's find the force of the applied but in a vertical direction, right? So if you take a look here, this 30 degrees is facing in the direction of the force that is applied in the vertical direction, so which means we're going to use sine. So we can simply say sine of 30 degrees is equals to the force applied but in a vertical direction divided by the force applied. So we do the cross multiplication. The force applied in the vertical direction is equals to the force applied multiplied by the sine of 30 degrees. So this is the value for the force applied in the vertical direction. So we can substitute both answers in this equation here, right? So now the force applied, or the force that is perpendicular to the surface, which is this one, it's going to be f of g cos of 10 degrees minus the force applied but in a vertical direction is going to be f of a sine 30 degrees. So this is your normal of the surface here, of the object. So now we're going to find the net force, F net, of the system. So to find the F net of the system, we need to look at forces that have an influence in the F net of the system. Number one, it is the force that is parallel to the system. Another one that has an influence, it is the force applied but in a horizontal direction, right? So the force applied but in a horizontal direction is this one here. Force applied but in a horizontal direction. So to find the force applied but in the horizontal direction, we're going to say, okay, fine. Looking at this triangle here, we're going to say, because it's the adjacent side of the triangle, we're going to say cos of 30 degrees is equal to the force applied but in a horizontal direction divided by the force applied. Then we do a cross multiplication. The force applied but in a horizontal direction is equal to the force applied multiplied by cos of 30 degrees, right? So this is the force applied in the horizontal direction. Another force that has an influence is this force here, which is the force which is parallel to the system. So how do you find the force which is parallel to the system, right? So we need to identify that too. So looking at this force parallel to the system, which is this one here, force that is parallel to the slope, right? Because we have the 10 degrees here, which is, if we look at it facing in the direction of the force parallel, we can say it is sine of 10 degrees. So we can simply say sine of 10 degrees is equal to the force parallel divided by the force of gravity. Then we do a cross multiplication. We're going to have the force parallel is equal to the force of gravity multiplied by the sine of 10 degrees. So this is the value of the force parallel. So now we can conclude in our F net and say, okay, fine, F net is going to be equal to these two forces here, force parallel and force applied but in horizontal direction. But now we need to look at which force is greater than the other. Because the system is moving upwards in an upward direction, it means that the force applied in a horizontal direction is greater than the force parallel. Then you're going to write the value of the force applied but in a horizontal direction, which is this one here. So it's going to be the force applied multiplied by the cos of 30 degrees minus the force parallel, which is this one here. So it's going to be f of g sine of 10 degrees. So this will be the answer of your F net, the net force of this object here, provided that the system is smooth and there is no frictional force acting on it. So now we're going to look at an object that is not in motion, right? So let's say this is the incline. So the incline of, let's say it's 25 degrees, and this is the object that is not moving, which is 1 kilogram. So now, because the object is stationary, there's going to be one force that has an influence in it being stationary or just being still on the surface of the slope, right? So let's first establish forces that act on this object. So the first force we find is the force of gravity. The second force we find is the F perpendicular. Another force we find is the normal, and another force is going to be the F parallel. Okay, so now let's first find the normal of the force, right? Or the normal of the object, sorry. So now, to find the normal of the object, we will have to look at the forces that are in direction with the normal. So in this case, it's only the force of perpendicular that is in line, not in direction, but in line with the normal, right? So if, let's say for example, this is the object, the normal will be this one, and the F perpendicular will be this one, right? So they're in line, but opposite directions, right? So that is the force that has an influence in the normal. So to find the normal, we'll say the normal is equal to the force perpendicular. So you can choose the direction, whether you say going downwards is positive or going upwards is negative, either way. But we know that it's going to be equal to the force of perpendicular. So how do we find the force of a perpendicular? We know very well that since here it's 25 degrees, it means that here it's also going to be 25 degrees. So the force of perpendicular, it's this one here. So it is at the adjacent side of this triangle. So meaning that to find that force, you're going to say cos of 25 degrees is equal to the force of perpendicular divided by the force of gravity. Then you're going to do your cross multiplication. So the force perpendicular is going to be equal to the force of gravity multiplied by cos of 25 degrees. So this is the value of your force perpendicular. So now your normal is going to be equal to the force of gravity multiplied by cos of 25 degrees. So if the direction is upwards, so you're just going to say upwards, right? So that's how you find the normal. So now let's find the forces that are acting on this object here. So the only force that has an impact on this object here is this force here, the force parallel, right? So how do you find the force parallel? The force parallel, it is this one here, the force parallel. So if you have the 25 degrees facing this direction, which means it's sine. So you're going to say sine of 25 degrees is equals to the opposite side, which is the force parallel, divided by the force of gravity. Then you do your cross multiplication. The force parallel is going to be equal to the force of gravity multiplied by the sine of 25 degrees. So that is your force parallel. So to find forces that are acting on this object, it's only going to be the force parallel. So you want to choose the direction. So the force parallel is actually your Fnet, your net force, which is going to be what we found here, F of G sine 25 degrees. Then you're going to indicate your direction of force. So in this case, it's going to be downwards, right? So that is how you find the Fnet of an object that is stationary in an incline and the normal of an object that is stationary in an incline. Thank you so much for watching. See you next time.